Previously, we covered the core foundations. Now, in Part 5, we tackle what you actually see when watching a rocket launch. Part 5. You've just watched a rocket climb through the thickest part of our atmosphere. But now something spectacular is about to happen. In this fifth part of our series, we're examining those mysterious expanding rings of vapor that appear around rockets as they punch through different atmospheric layers. Last episode, we covered how rockets interact with the dense lower atmosphere. Today's question: what creates those dramatic ring formations you see expanding outward from the rocket, and why do they appear at specific moments during ascent? These aren't random cloud formations, they're precise indicators of what's happening as the rocket encounters different atmospheric conditions. Let me show you exactly what you're witnessing. Tropopause Breakthrough. The most dramatic ring formation occurs when rockets break through the tropopause, the boundary between the troposphere and stratosphere. At roughly 10 to 15 kilometers altitude, depending on location and season, atmospheric conditions change dramatically. Below this boundary, temperature decreases with altitude. Above it, temperature begins increasing again. This creates a natural barrier where moisture and atmospheric dynamics behave very differently. When a rocket punches through this layer, it creates a shock wave that becomes visible as an expanding ring of condensed water vapor. The ring forms because the rocket's passage creates a pressure wave that propagates outward through the moisture-rich air at this altitude. Think of it as the rocket writing its signature across the sky at the exact moment it transitions between atmospheric layers. Weather's role in the show. High humidity makes these rings more prominent and longer lasting. On particularly humid days, you might see multiple rings forming at different altitudes as the rocket encounters various moisture layers. Conversely, dry conditions can make these formations barely visible or absent entirely. Wind patterns also influence how quickly the rings expand and dissipate. Strong upper-level winds can stretch the rings into oval shapes or cause them to drift sideways as they expand. This is why the same rocket type can produce vastly different ring formations, depending on launch day conditions. Temperature inversions, where warmer air sits above cooler air, can create additional ring formations at unexpected altitudes. These inversions act like atmospheric mirrors, reflecting and amplifying the pressure waves created by the rocket's passage. Viewing distance changes everything. Your viewing distance dramatically affects how these rings appear. From close range, say 3 to 5 kilometers, you'll see the rings form almost instantly after the rocket passes overhead. The expansion appears rapid, and the rings look relatively small against your field of view. From 15 to 30 kilometers away, the perspective changes completely. The rings appear larger relative to the rocket, and you can watch their full expansion cycle. This distance often provides the most photogenic view of ring formations, because you can see both the rocket and the complete ring system in frame. From very long distances, 50 kilometers or more, the rings might be visible before you can clearly see the rocket itself. They appear as slowly expanding circles that seem to emerge from a barely visible point of light. What this means for your launch experience. Understanding these formations helps you anticipate the visual highlights of any launch. The tropopause ring typically appears about 2 to 3 minutes after liftoff, depending on the rocket's trajectory and thrust profile. If you're watching in high humidity, keep your camera ready for multiple ring events. If conditions are dry, don't expect dramatic formations. Focus instead on other visual elements we've covered in this series. Most importantly, these rings represent real physics in action. You're watching the rocket's interaction with our planet's atmospheric structure made visible. It's a reminder that launches aren't just about escaping Earth. They're about understanding how our atmosphere works and how vehicles can move through it efficiently. Next episode, Part 6, explores the next key question in our series. What happens when the rocket finally leaves the atmosphere entirely? If you're finding these explanations useful for your launch viewing, consider subscribing for more grounded space science content. That is part 5 of what you actually see when watching a rocket launch. In part 6, we explore the next key question. Subscribe so you do not miss it.